Okay, calculus class, we're going to talk about section 3.3, and you have a handout, so hopefully you have that with you and you've actually read through the first page of the couple boxes. I'm just going to give a brief explanation of that, and then we're going to move right into an example. Basically what's going on here, if you have a function that is decreasing, so if the function is decreasing, like here, it's obviously decreasing and going down, its derivative is going to be negative. Think about it. The slope of a tangent line to this graph right here is going to be a negative slope. It's going downhill. This is constant right here. If the slope is 0, if this it's a horizontal slope, the derivative is 0, then this is a constant area. And then here, right here, we have an increasing area. If the derivative is positive, okay, that's a positive slope, the function is going to be increasing there. So we're going to use that information to figure out some things about a function, about where it's increasing and where it's decreasing. So on this example, you have a function, okay, and your first step, we're going to try to figure out where this function is increasing and decreasing without graphing it, okay? So first thing you want to do is you want to find the derivative so you can find the critical points. Basically, critical points are going to be changes in directions often, so that's going to be an interesting spot to look at. So the derivative of this function, we're going to figure that out first, is 3x squared minus 3x. Okay, that's the derivative of this function. So we're going to set that equal to 0 so we can find our critical numbers. Factor out a 3 and an x, so we have x minus 1. So our critical numbers are 0 and 1. So those are our critical numbers. Okay. Then we're going to set up our intervals with our critical numbers. So we're going to have an interval before, in between, and after our critical numbers. So here's an interval between negative infinity and 0. That's our first interval. And then we'll have an interval between 0 and 1, right in between our critical numbers. And then we'll have an interval from 1 to infinity. Okay? Now we're going to figure out some test values inside those intervals. So we have to come up with a number that is between negative infinity and 0. So x equals negative 1 is as good as any. We need a number in between 0 and 1, so let's just go with the half. And a number greater than 1, okay, so that's going to be, we'll just pick 2, okay? Keep it simple. So what we're going to do now is we're going to figure out what the signs of our derivative would be at those points, okay? So if I plug in a negative 1 into my derivative, okay, I am going to end up with a positive number. If I square a negative 1 and I subtract a negative, I'm going to end up with a positive solution. You don't have to actually calculate what it is. You just have to know if it's going to be positive or negative. If I plug in 1/2 into my equation, my function of the derivative, you are going to get a negative value. If you plug 2 in here, so you're going to square 2 and get 4, multiply by 3, put 3, get 12, and subtract off 3 times 2, we're obviously going to have another positive number. So our derivatives are positive in this interval, negative in this interval, and positive in this interval. So our conclusion is we are going to be increasing in this interval, we are decreasing in this interval, and we are increasing in this interval. So this function is increasing. It is increasing between negative infinity and 0, and also increasing between 1 and infinity, and it is decreasing between 0 and 1. Okay? The next video is going to have to do with using the first derivative test. So go ahead and look on your next sheet, on the next page of your notes sheets that I've given you, and I want you to read the definition of what it means to be a strictly monotonic.